Hi, Siqi. To begin with, I guess, what is your name? What grade are you in? And what school do you go to?
Yeah, so hi, I'm Siqi. I go to Iroquois Ridge and I'm in grade 10 right now.
Would you also be able to share a fun fact about yourself, unrelated to science fair?
Oh, yeah, of course. So, a fun fact about me is that I love noodles. So, whenever I go somewhere to eat noodles, I have like this little app on my phone where I'll actually like save the address and give a little like review of the restaurant to keep track. And honestly, if I didn't want to do STEM in the future, I'd want to go into like culinary or like become a food critic.
That is so interesting. I think I've heard of similar apps of rating restaurants, but I've never heard of anyone specifically rating noodle restaurants. That is
It's
really,
noodles. Yeah.
I love that. And now, congratulations on qualifying for ISEF. That is insane. Internationals, how are you feeling?
Oh, I'm so like I'm nervous, but I'm also excited at the same time. Like I'm so excited to meet all the amazing like mentors and like industry professionals and also just like other people who are just as excited and into science as I am. I literally took a look at the panelists that will be able to speak to, and I mean the list is just insane. So it's definitely a once in a lifetime opportunity and I'm really excited for it.
Well, for sure, you are so deserving. Not necessarily once in a lifetime, because maybe it'll happen again in the future.
Of course,
I'm
fingers crossed.
for you, but of course, just looking at the one this year, I'm sure you'll do great and you'll represent Canada well. So back to the roots of how you got started. What first got you into science fair?
Yeah, so honestly, the story is not as interesting as you would have hoped, you know? Like, I went to Morden, and at my elementary school, everyone had to do a science fair project every year. So in grade seven and in grade eight, for a big part of our science mark, we had to do a science fair project. But I think in this way, like, I got into the habit and I got a really good understanding of the scientific process. So I'm definitely thankful of my teachers at Morden for kind of cultivating the beginnings of my science fair journey. Yeah.
Yeah, for sure. I totally remember that. Um, is that where like your passion kind of started, or at that time were you kind of just like, this is such a boring school project, if you know what I mean?
No, I definitely like really liked science fair because I think it combines a lot of the skills that I really value. Like it's not just pure science, right? There's also that presentation component. There's also that delivery component to you and your judge. I just thought it was such a good opportunity, especially because I'm someone that doesn't do well on like pure assessment things. I really like having that space to kind of explore like project-based, inquiry-based learning. So BASEF and science fair in a whole was a really great experience for me at school.
For sure, it definitely sounds like the perfect project for you. I also remember, because since we did both go to Morton, I remember you did a project on CRISPR technology. So I was wondering if your project this year is about something similar or different.
Yeah, of course. So last year I essentially did like a theoretical review or like a literary analysis paper on CRISPR-Cas9 technology and using it in PDAC like tumor microenvironments. It was actually a partner project between me and you, and I think you remember. But that last year is completely different from this year in the sense like it was very much just a study, like a literature review. Whereas this year I have, you know, components of like innovation, I have components of discovery. I also tie in a literature review in there. So it's kind of interdisciplinary. And also this year, I'm still doing the same disease, which is pancreatic ductal adenocarcinoma, but it's from a computational biology project. So computational biology or like bioinformatics, it's a field where you combine a lot of like computer science and math to look at large sets of data to kind of tell a story or to discern the story. Yeah.
That's super interesting. Is there a reason that you chose that topic? Why do you think it matters?
Yeah, so I chose this topic because As of right now, PDAC has one of the lowest survival rates of any cancer, 12% in 5 years. And one of the biggest reasons is that chemo resistance in this cancer is extremely high. What we have right now in conventional methods for computational biology is we assume tree-shaped transitions or linear transitions. So this means that it cannot actually accurately represent the complex cellular dynamics that exist within this this type of cancer, right? Especially things like loops or like cyclic processes would be invisible. And my project kind of focuses on addressing this gap in our research and trying to apply something called topological data analysis, which looks at the shape and structure of a data, which normal methods would miss as of right now.
That's super interesting. And that's so inspiring as well that you really chose to dive into this very, I guess, not so commonly talked about type of cancer. It's a very genuine reason for you to be doing it. I find a lot of people when they choose kind of not necessarily a passion project, I guess, but kind of like that, it's typically regarding something that affects them or someone that like they love, or I guess like, I think you know what I'm getting at, but it's just so nice to see that you're really trying to just help the world, and it's wow.
Oh, thank you. Yeah.
Yeah, I remember that project from a few years ago doing pretty well too. I think you went to Canada-wide science fair and now international science and engineering fair. That's pretty impressive. Did you do any projects in between? Like, did you do project last?
No. So I did a project 2 years ago, and I did a project before that. But my grade 9 year was spent working on this same project that I only ended up presenting in grade 10. Yeah, because it took so long to go really in depth and develop it. Yeah.
It really shows your dedication and how much time and effort you spent on it. So I'm sure it is really well crafted. Now, more about this year's science fair. What methods or technologies did you use in your project? I know you already mentioned the topological data analysis, but is there anything else?
Yeah, of course. So with any bioinformatics or computational project, you need to start with a data set first. And I recommend to anyone watching, you should check out the NCBio database. And I specifically use the Gene Expression Omnibus, or GEO for short. Like, you'll see all the data sets, they have a code, and mine specifically for this project, they have the first 3 letters in front. This is basically just a public database where literally anyone, they can download data sets and they could run their own analysis, for curiosity or for research or for anything. And it's very accessible, so I would highly recommend. And then the actual computational pipeline was done in Google Colab, specifically using, a bunch of Python modules. And I use methods like persistent homology, which, is something from topological data analysis. And then to actually extract like a story from the cells, I use circular pseudotime. So this is a way of ordering the cells along like a trajectory to see what they're actually doing in my cycle. So for example, my persistent homology, it found like a significant loop in the data set, but I wouldn't know what's actually going on in that loop without using circular pseudotime. So the analogy I like to use is if I have like runners on a track, like maybe like you or I, like the track behind our high school, it's circular, right? And conventional methods would think of this circular track instead as a straight path, like a sidewalk. But with my data, looking at it like mathematically, you're able to see that if you took a snapshot of every runner on that track, it would be in like a circular fashion. And so using like pseudotime ordering, I can see like, okay, is our theoretical runner, are they like tired at the beginning of the track versus someone at the end? Like, are they someone at the beginning, are they like refreshed at the beginning of the track, so versus someone at the end, are they tired, or like just seeing how the cells and genes themselves progress along my cycle.
That's super interesting, and I really liked the analogy you used about that. It all sounds very complicated. So tying into how it seems very difficult, what would you say was the hardest part of your project, and how did you overcome that?
Yeah, so I would definitely say like the hardest part was not necessarily doing the project itself. It's having the tools and the right um, methods to actually start doing it. So because I don't have any like biology background at home, like both my parents are not in biology at all, I had to like self teach myself everything from like the coding to actually learning about the concepts that are required when I'm analyzing my results. And for anyone, like I would just recommend tutorials, YouTube, literally any of those free websites. They're so amazing, and they people have been generous enough to create these and teach online. And I think like now that we have the internet and we have Wi-Fi, all of this knowledge is available for you, so you should definitely try and independently learn. But also I started this project like October 2024, so it has been 2 years. I did end up getting a mentor like the beginning of 2026 this year, so they've definitely helped me with like furthering my scientific depth of this project. And also a big thing was they encouraged me to do the statistical testing on my results, which I think really helped me elevate the presentation. Yeah.
That's super interesting. So first, I think you mentioned there's quite a few different like resources someone could check out if they wanted to get started. Is there one in particular you'd want to recommend? Like,
ooh, that's hard. I mean, this may be like too cliche, but Khan Academy is definitely the best resource out there for anyone looking to learn like just general knowledge. It explains in such like short bite-sized content. It's really easy to digest. And then also if you're looking for like specifically my topic was kind of more niche, like you wouldn't find it on like Khan Academy. So you can go to YouTube and there will be like tutors and people that have published some of their knowledge on there.
yeah, I definitely agree. I love using Khan Academy. I totally think it's a great resource. And then for the second part, how you mentioned you got like a mentor. Is that someone from a professor from a university, or can you elaborate more on
So
that?
I talked with Dr. Fan. She's a postdoc at the Unity Health Network, and she was able to help me with some of the like scientific claims I was making,
Mhm.
and just kind of like being a second reviewer on my topic, right? Because I was doing this project entirely by myself from before that point, and I wanted to make sure, I was actually on the right track and not just trying to craft a narrative that didn't exist.
For sure. Would you say it was hard to get her to like reach out to her and to get her to help you out, I guess?
No, I don't think so at all. A lot of like scientists and researchers, there's super nice people, and they're really, really generous and kind. So as long as you make the first step to reaching out, I'm sure you'll get a response from at least, you only need one response out of the many that you
True.
attempt.
That is true. Yeah. I always thought it'd be really hard. Everyone has such busy lives, but that's great to hear that they're super nice and helpful, especially for some very complex projects like yours, or even with the simpler ones, I guess, to really help people like dive deeper.
Mhm.
Um, Back to your project though. Since we talked about the hardest part, now can you share about maybe your favorite part of your project?
Okay. So I think my favorite part was um it was like, so basically I wanted to see how my method, like the persistent homology approach versus the conventional method. So I also ran kind of, you can say, like a control with like clustering. It's specifically lead-in clustering, and I actually found that I was able to get 46 times higher accuracy or finer resolution with a persistent homology approach. So I think that was definitely one of my favorite figures and numbers to present to the judges, because it really showed that this can have some real-world impact.
Yeah, that's super interesting. I was literally about to ask then, how does your work apply to the real world then? Sorry, some of this terminology is a bit confusing to me. I'm trying to grasp all these complex.
Yeah, for sure. So my work mainly found that there was a significant loop involving these genes where they were in a low expression state, or what we call like basal state, versus when they were stress activated. And one of the main genes I found that had like promising cycling properties was GABRP. Right now, GABRP is only recognized as a static property of chemoresistance. But what I found actually in my research is that that's not true. Like, it's in a low expression state and then in a high expression state, and it comes back to that low expression state. It's a topological loop in my structure. And so after running through like these genes in a drug gene database, I found that right now we have 60 drugs that interact with this gene that could potentially actually target loop cells at a specific phase. So what this means is, like, since GABRP is only expressed highly in one phase of the cycle, if we could target a phase of the cycle where it's more vulnerable in chemotherapy, that could potentially mean changes to 60 of the 60 of our drugs right now, which presents a big therapeutic direction in chemotherapy treatment.
Oh wow! So does that mean so basically what you're saying is that you could target these cells and reduce pancreatic cancer?
Yeah, in like a vulnerable therapeutic window for them.
Oh, okay. So then that means like the death rate, the mortality rate wouldn't be as high, I guess.
Yeah, we like the hope in the very far future is that that would mean that the chemo resistance would be reduced, and also that the chemotherapies would have better impact on the patients.
Oh wow! So would this apply to only pancreatic cancer, or would it be to, like, I guess, more cancers as a whole, or whenever chemo?
So for these specific results, they would only apply to pancreatic ductal adenocarcinoma, because my data set was only ductal cells, right?
Mm-hmm.
But the actual pipeline itself, like, you could run it on any RNA sequencing data set and find results.
Okay, that makes sense. We've talked a lot about your work. I think we've already touched a bit on this, but what advice would you give to other students interested in starting their own science fair project?
Oh, this is my favorite question. So the first thing I would say is, like, don't play it safe. Part of my process was like so much failing, and your project is bound to fail at some point, whether that be like a little thing or like a major catastrophe. But that's not the point. Like, you have to fail in order to solve these problems. Like, for example, my project, like I said previously, I started in October 2024, and now we're in 2026. So, like, the amount of times, like, my system crashed, the amount of times my code just didn't work, or like I really didn't know what I was looking at with the numbers, like, that's all a part of the process, and that's something that's actually really compelling when you're talking to the judges. So definitely don't erase that stuff out. Like, it only shows how much more depth your project has. And also, it's totally okay to take a break. My project, because it failed so much, I didn't participate in last year's fair, and I only came back this year after 2 years of work to present this project. And so like I kind of went on a redemption arc, right? And then also, second piece of advice is to keep in mind the rubric. So BASEF is kind enough to literally release the rubric for their judges for you to see and to see exactly how they're grading your project. And so sometimes, you know, you have to look for those specifics, like they want your abstracts specifically on the table in a separate paper, or they want you to have a logbook detailing all of your materials, mistakes, and your dates. Like those are all points that are easily earned if you really just focus on the details. And then my last piece of advice would be to not overclaim your project. Like when I was talking to all my judges, I always say that this is, you know, a hypothetical direction or a future direction. You should never like say for sure your project is novel, because we don't know that you are the first person in this world to do it, right? And actually, one of my CWSF mentors, that was one of her main pieces of advice, is to not really never claim novelty if you aren't 100% confident, or if you don't have like a patent or something to prove it, right? Having precise and rigorous scientific language is always better than making these big claims.
For sure. Wow, I loved all three of those pieces of advice. They, yeah, they're definitely making me think of doing a science fair project, thinking back to those days. But yeah, anyways. Something else I did hear about was that your school, Iroquois Ridge, didn't have a science fair club before. So what inspired you to start it? Yes.
Yeah, so actually I'm not the like main founder. Like I'm a co-founder with Jasmine Wang. She's also been very successful at science fair. And I've always wanted to start like a science fair team at our school. Not necessarily because science fair is like a team event. It's about building that like community and like the finding those like-minded peers in the school that could just make the process more fun. So that was basically one of my biggest motivations. And also being able to, you know, share like resources and expertise and experience with one another can be really helpful. Like I said, it's always better to have like a second view on your project, which is one of the reasons I so thankful to my mentor. But not only that, but my friends and family have also taken a look at my project and given me really valuable advice on how to improve it.
For sure. Support systems are definitely so important, especially when working on such a long project like this one where you put in so much time and effort. Just having those people to back you up that it's worth it to keep going. Yeah. And I know you said that you weren't the main founder, but can you walk me through the process of how you started the club, like, or how Jasmine did then, I guess? Who did you have to?
No, we were co-founders, but
Okay.
the process of starting a club, especially at my school, is that you have to, before you do anything, you have to get a teacher supervisor. So my main thing is like just talk to everyone you know, right? And not only the teachers, but like students that you think would be interested in your club. Your first step is like getting the idea out there. So don't be like afraid of rejection, and especially don't be afraid of like awkwardness. So literally, at break, I remember me and Jasmine, we would just go knocking on all the English, gym, science, music teachers' doors, and we would just ask them whether they could supervise our club. And you know, like maybe like 99% of them said they were really busy or they couldn't. But one teacher, like Mr. Kirkhoff, he said, we can. So now we have a club. It only takes one yes out of like all of the no's. So don't be afraid.
Oh, that's so amazing to hear. Yeah, it's definitely hard to really put yourself out there, and especially when you're talking to staff, and even the ones that you might not know as well. So, but I'm so glad you were able to create it. Were there any challenges you faced when creating the club? And if yes, how did you overcome them?
So I think one of the main challenges was actually getting the club started, but we kind of talked about that already. I'm really grateful, honestly, to like the school and the administration for streamlining our process. I think they saw like the value of having students compete in science fairs. So we honestly had a pretty smooth process of starting a club before after we got a teacher supervisor. But I guess like a funnier story is that I remember our very first meeting, we double booked the room with the engineering club. So that was one of the challenges, was finding a new room.
That's a funny one. Wonder how that went. Oh boy. I think you were talking about this a bit, but how is the club doing now? Like, what has been the response from students as well as teachers?
Yeah. So honestly, the response from students and teachers have been amazing. It's like more than I ever hoped for. And I'm so grateful to be able to have like a community that allows me to do this. But mainly, I think it's about the sense that like the BASEF is free, right? Like it's free participation for any student that comes. But you get these amazing like awards and scholarships and opportunities and these like fully funded trips. So I think a lot of people are just now finding out about science fair. So I'm really excited about, hopefully our new members joining in the next year.
That's so great to hear. So then, in the long term, what sort of impact are you hoping the club will have?
Yeah, mainly I just want to be able to continue to have this community where we like support each other and we help look at our projects and give constructive feedback. But our main goal, like I've always put it out on social media and in our club meetings, we want to win the best high school trophy award, because that just really like solidifies our standing as a team, right? But in a more serious way, I definitely do feel like um, just like how DECA and HOSA at other schools, they have these like very like team spirit, like mascot vibes. I want to be able to establish that same branding with the science fair at Iroquois Ridge.
Yeah, no, that's great. I know it's your first year, so it's too bad. No, I think no award, question mark?
No, we didn't get the best high school award. That went to Abbey Park.
Okay. That's okay. I know Abbey Park has some wonderful science fair participants, but I did see on your Instagram that you had one ISEF person as well as 5 people who are going to.
Yeah, amazing. Seriously, like even though we didn't win the best high school award, like
that's phenomenal.
So well, like we had, I think it was 3 silver merits. No, yeah, 3 silver merits, 4 gold, just out of the 9 projects we had. So an incredibly high caliber of our members participating. Yeah.
Not even the caliber though. I'm very impressed that you were able to get 9 projects to science fair, especially since it's only the first year. Because I know how long it takes to make a science fair product, the dedication, the time you have to put into it, as well as the passion. So just having 9 starting out that all did so wonderfully, I just know your club will continue to do some great things.
Yeah.
Of course. And then more towards other students, what advice would you give to them to anyone who is hoping to start a club or initiative at their own school?
So I'm someone that like actually, contrary to my science fair project, I don't like working alone. And it's so important when starting a club or initiative, you actually want members to come, right? Because otherwise it wouldn't be a club or initiative. So definitely finding your team, finding your support group and people that will want to work with you and share the same goal is very, very important. And I'm so grateful to my co-president Jasmine and also to the execs we have at Science Fair team. Also, I think one of the biggest things, kind of alluding to that, is you really do want members. So starting a successful like social media or promotions is very, very important to any club.
For sure, yeah. I think promotion is one of the main parts of every club to really just get more people to join, people to participate, for sure. Well, I think that's the last of my questions. Thank you so much for meeting with me today. I know we had some technical difficulties at the start. And thank you so much for talking to me and sharing all about your love for noodles, as well as your experience at Science Fair. And finally, more about just how to start a club and all your advice. I really appreciate it. Oh, and of course, congratulations again on making it to on qualifying for the International Science and Engineering Fair. Again, I just want to say so well deserved. I always saw it coming. Like, you're just so amazing.
Well, I gotta thank you for the opportunity to have this interview. It's been so fun. And also congratulations to you. Like, you were elected for student trustee. Obviously, was always rooting for you.
Thank you. I really appreciate the support.